All right, everyone, let's take a look at this one. It's a really clean geometry setup and the payoff at the end is very satisfying. We're looking at two concentric circles and there's a chord drawn in the outer circle that's tangent to the inner circle. The question is, can we find the area of the region between the two circles using just that chord? Before we jump in, pause the video for a moment and see if you can already guess the trick. Think about what tangency really means here and what kind of triangle you might be able to spot. All right, let's build the picture step by step. We start with the center of both circles and we call it O. The inner circle has radius R, the outer circle has radius capital R, and the shaded region between them is what we usually call an annulus. The area of that annulus, just as a reminder, is pi times r squared minus r squared. Now here's the key geometric condition. The chord PQ is tangent to the inner circle, which tells us a lot. Because the chord is tangent to the inner circle, the radius drawn to the point of tangency must be perpendicular to the chord. So we drop a segment from O straight down to the chord and it hits the chord at point M. That segment OM is perpendicular to the chord and its length is R. Next, we look at the chord itself. We're told the full length of the chord PQ is 12, so naturally the midpoint M splits it into two equal pieces. That means MQ has length 6. Now pause and look carefully at triangle OMQ. We have OM, which is R. We have MQ, which is 6. And OQ is a radius of the outer circle, so its length is R. And because OM is perpendicular to the chord triangle, OMQ is a right triangle. So without doing anything fancy, we can apply the Pythagorean theorem to triangle OMQ. The hypotenuse is OQ, which is R, and the legs are R and 6. That gives us this expression, r squared equals r squared plus 6 squared. So immediately we can rewrite that as r squared minus r squared equals 36. And notice how perfect that is, because the area of the annulus is exactly pi times r squared minus r squared. So we don't even need the individual values of r and r. The geometry hands us the difference directly. That means the area of the region between the two circles is pi times 36, which simplifies to 36 pi, and that's it. No calculus, no heavy algebra, just one right triangle hiding in the picture. So the big ideas to remember here are tangency gives you a perpendicular, the midpoint of the chord gives you a right triangle, and once you see that triangle, the area falls out almost instantly. If you enjoyed this one, go ahead and like the video, drop a comment saying 36 pi so I know you followed it through, and subscribe for more geometry problems where a single clever observation solves everything. See you in the next one.